we see this problem. We see two constraints. One is bricks and one is ladders. This is a trade-off, which is to find the output of the range of the heights. So in that way, we can think we have two methods here. One is we can use the heapq to maintain the maximum, and the other one is we can use the binary search, which is the lower band will be the 0 and upper band will be the length of heights. Let's see the heapq first. So the key things here will be we can use the bricks for all the start, and once we found out we already use all of the bricks, we have to use a ladder. Then we just heap up the maximum of the gap, and then use a ladder to switch for it. So it's a one pass, and we have to maintain heapq, which will be log n to maintain it. And the diff will be the height difference. If the height difference is smaller or equal to 0, then we can do nothing. Otherwise, we have to use a bricks for this diff at the start, and we push it into a heapq. Since in the Python is a default minimum heapq, so we push the negative number of it to every time we can pop the largest gap. And S means the sum, which is the sum of the bricks we used. If the sum of the bricks we used is larger than the bricks we have and the ladders are greater than 0, then we can use the ladder to switch for a used gap. Then we just heap pop and S plus that. Remember that we pushed a negative number of it. Otherwise, if S smaller than bricks, we can continue to add more bricks here. And otherwise, we don't have any more ladders, and the S is still larger than the bricks we have to return the current I. And if we can go through one pass all of it, means our bricks plus the ladders are enough for reaching the end of the heights. Then we directly return this. As I mentioned, which we can use the binary search as well, which is this is the initial method I just wrote, but I have to say that I found out that the binary searching this problem will be harder to implement than what we have in the heapq. But simply speaking, if we found out it's invalid of the mid, we push the right to the mid. And what do we say is invalid or not? Which is we sort of from the start to the current all the bricks, and we see whether we can use the ladders and bricks to make it valid or not. If it's invalid, means we have to step smaller. So R equal to mid. Anyway, I still recommend to use a heapq in this question.